Hey everyone, welcome to Dr. Seremba Online School. My name is Katerega Fred. I'll be taking you in pure mathematics. I know you are going through tough times of this COVID-19, but feel at home. I know you're going to enjoy this class. Now let us begin. I'm going to take you in integration part 2. It's a continuation of integration 1, which I know you covered the definite, indefinite integral, volume of solid of revolution. You learned how to integrate and area and a curve and so on. Recall hope everyone you recall from integration 1, hope you were told this basic, that the integral of x power n dx is the same as x power n plus 1 out of n plus 1 plus a constant of integration, that when you're integrating, you increase the power by 1 and you divide by that new power, where c is the one which is known as the constant of integration. Then we can go on to our integration 2. Some of the techniques we are going to look at. Basically, we are having the technique known as recognizing the presence of a function and its derivative. We are going to recognizing the presence of a function, and its derivative. So, what is to recognize the presence of a function and its derivative? Here, we try to guess the derivative from where the function came from. For example, you can take an example. For example, they can give you that integrate 2x dx. When you're recognizing the presence of a function and its derivative, you try to guess what did they differentiate to get this 2x. I know everyone understands that when you differentiate x squared, you can get it to what? 2x. That's what we mean by recognizing the presence of a function and its derivative. Then you add just the numerical factor. Therefore, the solution to this one, you're trying to guess that it is coming from d dx of x squared. Everyone look at this. When you differentiate x squared with respect to x, what do you get? Drop the power and reduce 1 from the power. That means when you differentiate x squared, you are getting 2x. And 2x is the one they are asking you to integrate. Then let us add just the numerical factor. Therefore, we are going to remain with the dx squared is the same as 2x dx. So now when you reach at that step, you introduce integral signs on both sides. You integrate dx squared, you also introduce an integral on the right hand side, and now this is the question. Therefore, integral of 2x, the answer becomes this one. X squared plus c is equal to integral of 2x dx. That is the answer. So that is what we mean by recognizing the presence of a function and its derivative. You just guess what did they differentiate to get that. Then many of you can wonder, you can be asking yourselves, where has the d gone? If you recall very well, you can be asking yourself, how has the d disappeared? So integral, for example, of dx, the answer is x plus a constant. Then also ask yourself, where has the d gone? Therefore, you just mind about this one which is in the brackets, so that d just disappears. You remain with that. Therefore, I can give you another example. Example 2. Example 2. For example, they can tell that integrate. Now this is a trigonometrical function, like integrate cos x dx. So if you're recognizing the presence of a function and its derivative, how do we apply that technique here? We are going to try to guess what did they differentiate to get a cos. You all know that when you differentiate sine, you get a positive cos. Therefore, our solution using the method of recognizing the presence of a function and its derivative goes like this. From d dx of sine x. When you differentiate a sine, you get a cos. Therefore, try to adjust until when you get something which relates to the question. So we say d sine x is equal to cos x dx. Then after reaching this step, you introduce integral signs on both sides. Integral of d sine x is equal to integral of cos x dx. Now when we reach there, that means that our answer is going to remain as sine x plus a constant is equal to integral of cos x dx. So when you integrate cos x dx, you're going to get sine x plus a constant of integration. It's all about guessing from where the derivative from which the function comes from. So that is it, that when you integrate a cos, you are getting a positive sign. Then to give you another kind of different example but related to that, we can have something like integrate x into 3x squared plus 2 power 4 dx. Now look at that. How do you handle that? This one also requires to recognize the presence of a function and its derivative. And remember, in the first place, I told you that when we are recognizing the presence of a function and its derivative, we try to guess the derivative from which the function in this integral sign comes from, or in the integrand. Where does it come from? So it's not about mere guessing, but you try to guess such that when you differentiate, this question must come back. So in this case, how do you guess? You just raise the power by 1. You raise the power by 1. So after raising the power by 1, if you differentiate and you see that this expression in the integrand comes back, then that means the method of recognizing the presence of a function and its derivative is applicable in this case. Let us try and we see. So from d dx, this means I'm differentiating with respect to x, of 3x squared plus 2. I've told you we are going to raise the power by 1, such that after differentiation, you will know that the power is going to come in front and reduce 1 from this power. So the power will be going back to 4. So let us try it. But the technique is raise the power by 1. So I'm going to add 1, it becomes 5. Let us try to differentiate this one very fast without showing the working. Drop the power, you drop the power. Now the power is 5. After dropping the power, differentiate the bracket. So look at this bracket. When you differentiate the bracket, we are going to get 6x. Now this one is a constant, we get 0. So 5 into brackets, that is 6x. Then you bring back the original bracket, but from the power you reduce 1. So I have told you, let us repeat it together, that you drop the power. After dropping the power, differentiate the bracket. that is 6x. After differentiating the bracket, bring back the original bracket, and from the power you subtract 1. So let us bring back the original bracket. The original bracket is 3x squared plus 2. I've told you from the power subtract 1. So now look at what you're having on the right hand side. Does it resemble something you're having in the question? Yes. I know some of you are worried about this 5 times 6, which is going to bring us a 30, but we are just minding about this function. Once the function comes back, then you can continue with that technique. So this means we are going to have d 3x squared plus 2 power 5 divide by, this is 5 times 6, which is the 30. So you divide by that 30 down, is equal to x into 3x squared plus 2 power 4. Then this dx, take it the other side. So that's what we call adjusting the numerical factor when we are using this technique. You can see that something which is in the question is coming back. Therefore, recognizing is applicable. Then what do? We are going to apply integral signs on both sides so that it matches with what is exactly in the question. So we introduce integrals. Integral on this side, 3x squared plus 2 power 5, then is equal to integral of x, 3x squared plus 2 power 4, the what? The x. Are we together there? Then when you reach this step, automatically this is the question. Therefore, our answer will just become 1 out of 30 into bracket 3x squared plus 2 power 5 plus a constant of integration is equal to integral of x 3x squared plus 2 power 4 dx. Here in this case, don't worry, as long as there is this integral and d, automatically for them they disappear. You remain with 1 out of 30 into this 3x squared plus 2 power 5 plus a constant of integration. And remember very well that integration and differentiation, one is the opposite of the other. So if you want to check that your answer is right, what you have got after integration, when you differentiate it, you will go back and get exactly the same thing. So now, hope you have mastered something on that. Hoping to meet you again when we continue with other techniques.